Hello guys. So I welcome you to the lecture series on real analysis, and I hope from the last two lectures you got it that what is the importance of this subject. Real analysis means we try to actually analyze the real numbers. Okay, but the basic things that you have to start with for that is the set theory portion that we have already started for the first lecture. In the first lecture, we have gone through the definition of set, representation of set, right? And in the last lecture, we have gone through many important topics like equality of set, subset, superset, and the concepts related to them. Well, you will find the lecture links for the last two lectures in the description box below. If you have not gone through them, please check those links. Well, I'm going to start today's lecture. Well, so you actually got the idea of what is set, when, what is subset. These facts, you know it, right? Now, after that, what we'll got is the complement of a set. That is also I have described with examples in the last lecture, right? So basically, we have an universal set. Universal set is the set for which or with respect to which other sets are subsets of it. Means this universal set contains all the sets. Now, if S is the set and X is the universal set, please don't go to strictly by the symbols. You may find different symbols to represent them in different books, different textbooks. You'll see capital U is many times used in different books to represent universal set. But the book I am referring here, it is mentioning X. So it doesn't matter actually, the concept is what does matter. So say X is the universal set and S is any set, right? Then SC we have defined as what? The set contains all those elements. X belongs to X, capital X, but here this X does not belong to S. What does it mean? Means SC contains all the elements of X, means universal set, which does not belong to the set S. Right. Then also we got another thing that is known as power set. Power set means what? All the subsets of a particular set S. So let's take an example. Okay, I'm taking an example. So say A is equal to 1, 2, 3. Okay. Then what will be the power sets of A? Power set of A means all those sets which are subsets of A. तो यहाँ सबसेट्स क्या क्या हो जाएगा? देखिए 1 we have 1, we have 2, right? We have 3, we have 1 and 2. Similarly, we have 2, 3, right? We have 3, 1. We have 1, 2. See, last class I told you that a set is a subset of itself, right? And this one, that is phi or null set. That is a subset of every set. So we got the power set of A is 1, 2, 3, 1, 2, 2, 3, 3, 2, 1, 1, 2, 3, and 5. How many elements we got the power for the power set of A is 1, 2, 3, 4, 5, 6, 7, 8. Now, sometimes you may be asked that how many elements are there in a power set of a set containing n elements. मतलब एक सेट दिया हुआ है जिसमें n एलिमेंट्स है, से a n, मतलब क्या है, a में आपका कितना एलिमेंट्स है, n, number of elements. Then power set of A will contain how many elements? That will be 2 to the power n. Okay. See, in this example, A is equal to 1 to 3. ये हमें दिया हुआ था. I just prove it. I just found the power set of A. तो कितना elements मिला था मुझे? 8. I have got 8 elements for this. So how I have calculated it? Say put 3 in place of this n. Okay. So you will get how much? 8. Right. So that's how we calculate power set and the number of elements containing the power set contained in that power set. Okay. Is this clear? I hope this is clear. Then these two examples I asked you to try it. Okay. So X is a universal set and let S be a subset of X. Then P of 0 means that no elements exist for that set, void set, or you can say null set. Obviously, what will be the power set for this? कोई भी एलिमेंट नहीं है, तो वो जो 0 मैं पहले ही दिखाया था आप लोगों को, by this O, you can consider it O as an empty set or null set, right? So इसका power set क्या होगा आपका? Power set of this will be nothing present in this element, in this set. So just this one, right? Is any confusion? I hope there is no anyone. And if there is any confusion, then please ask. Then next thing is that complement of this one. Means double complement is there. Okay, double complement is there. So SC का मतलब क्या है? SC means what? Those elements which belongs to X. X stands for our universal set, but does not belongs to S. But now, if we take complement of it again, then we need to consider. See, I am going to use the Venn diagram. That will be more clear for you. एक Venn diagram बनाते हैं हम, ठीक है? ये हमारा universal set है, और इसमें से this one is S. So of course, what will be the S? See here. So if this is this is S and this is X, which portion will represent the SC? Can you tell me? Of course, this portion, right? So ये portion जो है, ये आपका हो जाएगा SC. The one I am representing with red color. Okay, this is SC. Now, I need to take complement of this SC. So, if I will take the complement of SC, मतलब those elements which is present in X but does not present in SC. So clearly, that will be our S. यहाँ डायग्राम से साफ दिखाई दे रहा है. That's why I have used this Venn diagram. So that element will be our this one. So from the Venn diagram, it is very clear that complement of complement S is S itself. Believe me, these two are very important property. So please note down these two, right? और जैसे मैं आपको यहाँ प्रूव करके दिखा रहा हूँ, आप सभी जने क्या करो, इसको कॉपी में नोट डाउन करके जाओ. ठीक है? That will help you. Let's move ahead. Let us consider the sets S and T given as S1, 2, 3, 4, 5, T, 3, 4, 5, 6, 7. Now, construct a new set 1, 2, 3, 4, 5, 6, 7. Note that all the elements of this set have been taken from S or T, that no element of S and T is left out. And this is known as union of S and T. Now we are talking about actually the properties or the operation, sorry, not properties, the operation of set. तो पहला property, पहला operation, sorry, जो मैंने यहाँ mention किया, वो what is that one? That is union. So union, how we go for finding union? Let's A and B are two sets, then union will be A union B. That will consist of all those elements X where X belongs to A or X belongs to B. Is this clear? तो यूनियन में हमें सारे एलिमेंट्स लेना है. ठीक है, ए और बी का सारे एलिमेंट्स लेना है. हाँ, रिपीटेशन नहीं करना है. सपोज ऐसा हो गया आपका, मैं ए का एग्जांपल एक सेट ले रहा हूँ 1, 2, 3. बी का एक एग्जांपल ले रहा हूँ 3, 4, 5. तो जो ए यूनियन बी होगा, ये क्या होगा आपका 1, 2, 3, 4 and 5. यहाँ आप देखो, ये जो 3 है, this 3 is actually present in both A and B, but I am taking only once. So that means we don't need to repeat. We don't need to write twice. We need to write only once, but we need to take elements from both the sets. Remember that here we are using OR. Okay, so that is union. Clear? So again, let us consider another set 3, 4, 5. This set consists of elements that are common both S and T. जो यहाँ एग्जाम्पल दिया हुआ है, उसके अकॉर्डिंग हमने और एक सेट बनाया जिसमें आपका 3, 4, 5 ये. Now, if you look at the sets carefully, you will find that this 3, 4, 5 present in both the sets. So this is actually common, and that is known as, that operation by which we go for finding this is known as intersection. Okay. So how we go for writing intersection? Intersection हम कैसे लिखेंगे? We will represent them with this symbol, and this will contain all X where X belongs to A and X belongs to B. देखो यहाँ मैं and यूज कर रहा हूँ. यूनियन में मैंने यूज किया था और. नाउ in intersection actually I am using and. Is this clear? It's a very simple fact, but you have to have clear idea on that, right? So now in this books, the book I am referring, they are using these symbols. Okay, S, it look like N, but actually this one. Okay, just concentrate on the concept. ठीक है, so हमारा जो concepts है, the two concepts that I have just covered, union and intersection, I hope this is clear to you. ठीक है? Now आप लोगों के लिए कुछ laws हैं. Sorry, I just some water. Okay. These laws you have to remember. Okay. You please try to prove them by yourself also. Although I'll show you. A union B is equal to B union A. एक law है आपका first that is known as commutative law. Yeah? Commutative law. And according to commutative law, A union B is equal to B union A. And A intersection B is equal to B intersection A. तो ये जो यूनियन है और ये जो इंटरसेक्शन है ये कम्यूटेटिव लॉ को सेटिस्फाई करते हैं. ओके, दिस टू satisfies commutative law. Then next is we have associative laws, that is A union B union C is equal to A union B union C. Similarly for A intersection B intersection C is equal to A intersection B intersection C. आप लोग क्या करो, कुछ एलिमेंट्स लो. You take, how you go for proving it is that just take few elements of A, say 1, 2, 3, 4, 5. A के लिए ले लिया मैंने. And for B I am taking say 3, 4, 5, 8 and 9. Now जैसे मैंने आप लोगों को दिखा दिया था कि कैसे यूनियन और इंटरसेक्शन निकालना है, ठीक है. So with those examples, you try to first find out this fact and try to prove LHS is equal to RHS. मतलब क्या है, आप लोग पहले लेफ्ट हैंड साइड का, जैसे कि मैं एक सिंपल एक दिखा भी देता हूं, रुकिए. से A union में I am trying to prove associative law. ठीक है, please concentrate. I am trying to prove associative law for union. How I will do that? A union B union C. तो मैंने आपको अभी A और B क्या लिया था, दिखा दिया था. Oh, I have erased it. So I am writing it again. Don't worry. Say मैं A 1, 2, 3. I am making it simple. And B say 3, 4, 5. ठीक है. तो A union. अब B union C, what will be B union C? तो C भी मैंने एक सेट मुझे लेना पड़ेगा. C मैंने ले लिया से 4, 5, 6. Okay. So B union C will be what? B union C will be 3, 4, 5, 6. Because you know that B union C I have to consider all the elements of B or C. Means the element should not be repeated. I need to write only once, but I have to consider all of them, right? So 3, 4, 5, and 6, right? Then A, what is A? A is 1, 2, 3. Again, if I am taking the union of 1, 2, 3 with 3, 4, 5, 6, what I will get? 1, 2, 3, 4, 5, and 6, right? So that's the left hand side of the equation given, right? Now I need to find out the value for right hand side. So that's very easy, because now I have to first find out the value of A union B. A union B is what? A union B का वैल्यू क्या होगा आपका जो दिया हुआ है? 1, 2, 3, 4, 5. Now A union B I have found out, and this is this one. Now let's take union of C with this union of C, and I'm taking, I'll get 1, 2, 3, 4, 5, 6, 4, 5, 6, right? So if you consider this is left hand side and this is right hand side. राइट हैंड साइड में भी मुझे जो सेट लास्ट में मिला वो है 1 2 3 4 5 6 and left hand side I also get 1 2 3 4 5 6. So this means left hand side is equal to right hand side, and this proves the associative laws do exist or do satisfy with respect to union. Similarly, find it out for intersection. Clear? So I hope this is clear. Now let's move ahead. These are also some important facts that A union A is equal to A intersection A is equal to A union phi, that is null, is of course A, and A intersection phi, that will be phi. यहाँ I think कुछ confusion होने की जरूरत नहीं है, फिर भी आप देखो A intersection phi, ये आपको क्या मिलेगा? null set, none, nothing. Why? Because see, sorry, A and this does not contain any elements. So आप intersection लोगोगे तो कोई भी common नहीं मिलेगा. So that's why this one. Similar बात इसके साथ when you perform union, then यहाँ तो कुछ elements है नहीं. When you perform this union, of course you will get A itself. Clear? So ये जो properties है, A union A is equal to A intersection A is equal to A, and this A union null set is A and A intersection null is null. Please do note that. Right? Very good. Now, given any two sets, I'm moving ahead. Given any two sets, we can construct a new set in such a way that it contains only those elements of one of the sets which do not belong to the other. Then that is known as difference of the given sets, and represented by either S minus T or T minus S. अब ये क्या है? This is known as difference of sets. The A element, one set we have S, and another set we have T. Now S minus T क्या होगा? S minus T will be those X which X belongs to S, but X does not belongs to T. एक example ले लीजिए. Please consider this example. S is given as 2, 4, 8, 10, 11. T is given as 1, 2, 3, 4. Now S minus T will be what? Those elements contained in S but not in T. 2 containing T, 4 containing T, 8, okay, 8 is not present in T, so I can write it. 10 not present in T, so I can write it. 11 not present in T, so I can write it. So S minus T will be 8, 10, 11. Right? Similarly, you can calculate T minus S. Good. Now, let's move ahead. Consider a collection of sets S where Si, okay, this is Si, okay, over some index set J. This simply means that to each element I belongs to J, there is a corresponding set Si. For example, the collection S1, S2, St could be expressed as Sij. Okay, where n is the index set. तो ये एक नोटेशन है कैसे आपको रिप्रेजेंट करना है. सपोज हमारे पास S1, S2, S3 ऐसे हैं, तो मैं इसको कैसे लिख सकता हूँ? हाउ आई कैन राइट दिस, इन व्हाट वे? Very simple. Si. Okay. And this I, from here you can see that this is natural number. So I belongs to N. Okay. Suppose I think this is clear. Now with the introduction of an index set, ab yaad rakhna, this N is known as what? Index set. Index set. A Q index set because this actually consists of this index 1, 2, 3 इन सबको हम क्या बोलते हैं? Index. ठीक है? Now, with the introduction of index set, the notion of the union and intersection of subsets can be extended to an arbitrary collection of sets. Okay. Now, how we can write that? Union of Si, I belongs to J, will be union of X belongs to Si for at least one I belongs to J. Right? Similarly for intersection and similarly for complement. Let's take one first. I'm considering this one. Si. Then I can write this as what? Union I belongs to J X such that X belongs to Si for I belongs to, for at least one I should be there for which, sorry, I belongs to J. ऐसे लिख सकता हूँ? Am I or not? Yes, I can write that like that. Why? See, union of Si where I belongs to J. ठीक है, हम इसका मतलब क्या कर रहे हैं? S1 हो गया, S2 हो गया, like that, Sn. So I am taking union of all these sets. So it will consist of all those elements X where X belongs to Si for any at least one I in J. तो X कोई ना कोई एक S में तो रहेगा, चाहे S1 हो, S2 हो, है ना? So ये elements, these elements, X maybe belongs to this one, or this one. Okay, so this elements, will get this. That's why I'm writing union of Si. I goes for I belongs to J. Index set is J actually. So I is equal to union of I belongs to J of X where X belongs to Si. For at least one I belongs to Z. Okay, the first one is clear. So similarly, please try to prove this one. Okay, एक intersection के लिए और एक complement के लिए. Okay, clear? I'm moving ahead. Now, next point that I'm going to discuss is function. Very important thing. Okay. I have to give credit to IGNOU because of the very good standard books, and the books I'm referring also. I have gone through many textbooks and IGNOU's reference books also. I have found the IGNOU's books very helpful. So that's why I'm referring them also. So let's take an example of this with respect to IGNOU. Let S be the set of all books in IGNOU library and N be the set of all natural numbers. Okay. Assign to each book the number of pages the book contains. Yet each book corresponds to a unique natural number. In other words, there is a correspondence between the books and the natural numbers. That is, there is a rule or a mechanism by which we can associate each book one and only one natural number. And this particular thing is known as mapping. So क्या example मैंने लिया? IGNOU library सारे books and से S वो सेट है जिसमें हम हिप्नो के सारे बुक्स को रखें, book 1, book 2, like that, book N. Now, for every book, we try assigning one number. Okay, say assign to each book the number of pages the book contains. Say B1 is containing 20 pages, B2 containing say 30 pages, like that. And say each book corresponds to a unique natural number, and I am assigning every book one unique number. So what happens? We should have a mapping. We should have an association between these books and the number assigned to it. ठीक है, अलग अलग बुक है, अलग अलग बुक में अलग अलग नंबर ऑफ पेजेस हो सकते हैं, राइट? नंबर ऑफ पेजेस में भी सेम ऑल्सो, बट दैट डजंट मैटर, द नंबर मैटर, number that we are assigning to the books matter. So what I mean to say that these books which have been assigned particular number, to recognize them, to easily access them, there should be an association between those numbers and this. So that association is known as function or mapping in mathematics. Right, clear? So let's come to the definition part. Let S and B P be to a non-empty set, a function f from S to denoted as f goes from the function goes from S to T, is a rule which assigned to each element of the set S a unique element in the set T. ठीक है, f function from S to T, और क्या definition बोल रहे हैं? Assign every element of X with some element, say Y of T. Okay, that is unique. Now the set, this set S is known as domain. Okay, that this S is known as domain, and this T is known as codomain. What? Codomain. Right? ठीक है, तो S जो है वो डोमेन है और T जो है वो कोडोमेन है. If an element X in S corresponds to an element Y in T under the function F, then Y is called the image of X under F, and that is expressed by writing Y is equal to Fx. The set Fx, X belongs to S, which is a subset of T, is called the range of F. If range of F is equal to codomain of F, then F is called onto or surjective function, otherwise it is called an into function. Now मैंने यहाँ पे बहुत सारे important points एक साथ बोल दिया. Let's take them again. I'm repeating it again. So first जो concept है image. What is image? Say X जो है X belongs to S, और इस X के रेस्पेक्ट में एक एलिमेंट Y है, कहाँ पे? आपका T. और आप जानते हो हम किस चीज की बात कर रहे हैं? What I am talking about is what? Sorry, this should be. What I am talking about is F goes from S to T. Okay, so then if for an element X of S we have an element Y of T, right? Then this Y will be known as image of X. Image of X. And how we write it as Y is equal to fx. Okay, and वो सेट जिसमें सारे इमेजेस हैं, वो सारे एलिमेंट्स x के, सारे x के एलिमेंट्स के इमेजेस हैं. Say this set where x belongs to S. Right? And this is known as range of F. Okay. The set fx, x belongs to S, is now the subset of T. Now, इसको क्या बोलेंगे हम? Range. किसका range बोलेंगे? Range of our function f. And if I am representing it by R, of course, it is very clear that R is a subset of T. क्योंकि R में वही सारे एलिमेंट्स हैं जो T में है, right? So R is a subset of T. So range is a subset of T. Now, if so, R is equal to T. You know T is what? Codomain. Don't forget the terminologies. S is domain and T is codomain. If R is equal to T, then in that case, I will call this function f as onto. क्या? Onto. ठीक है, मैं एक बार फिर से रिवाइज कर रहा हूं. अगर आपका जो रेंज है वो कोडोमेन के बराबर है, मींस range is equal to 3, then that function is known as onto or surjective function. अगर नहीं है, if it is not equal to T, then this is known as into function. Is this clear? So we have gone through several terms. First, domain, codomain, image, range, onto function, and into function. Onto function, when it will be onto, if the range is equal to the codomain, and if it is not equal to, means if it is not equal, range of f is not equal to codomain, then it is known as into. That is onto, into. Clear? Okay, very good. Now, suppose S is equal to 1 to T4, T is equal to 1 to T4, 5, 6, then F as goes from T is defined as Fn is equal to n plus 1. अब ये इस फंक्शन को ध्यान से देखो, मैंने क्या लिखा? Fn is equal to n plus 1. Right? क्योंकि देखो, for any element of S, we have an element in T. Say F1, 1 plus 1, 2, 2, 2 plus 1, 3, T, T plus 1, 4, 4 plus 1, 5. Yeah, of course, here one more element is there. So if I say range, if I will find out the range, then what will be the range here? F of 1, मैं एक बार दिखा रहा हूँ, प्लीज ध्यान से देखिएगा. F of 2, F3, F4. So F of 1, how much I got? 2, 3. F of 2 is 3. F of 3 is 4. F of 4 is 5. So that is our range. But this is not equal to T. That is, range is not equal to codomain. This T is codomain, right? So our function is onto or into. If range is not equal to codomain, then that function is known as into function. Okay? That function is known as into function. But now if we consider another function, S for S 1 to T4 and T is 1, 4, 9, 6. That is, F goes from S to T such that Fn is equal to n square. Right? See, every element is a square of this elements of S. So here range is what? Range of this function 1 square f of 1 is 1 square, 1. F of 2 is 2 square, that is 4. F of 3, t square, 9, 4, 16. That is equal to t. So range is equal to codomain. And if it is range is equal to codomain, range equal to codomain, then that function is known as what? That function is known as onto function. Right? So I hope this into and onto concepts are clear. I hope this is sufficient for today. And in the next case, we'll discuss the further concept of one function. Right? तो नेक्स्ट क्लास में मिलते हैं. आज के लिए इतना ही. थैंक यू very much.